So first things first, the first part of Unit 9 is, again, like I said, going back over Pythagorean theorem. Go ahead and highlight the words Pythagorean theorem here. This is what we're going to be using all day today. Pythagorean theorem describes the relationships between the side lengths of a right triangle. So we are dealing with only right triangles today. Please go ahead and put the little right triangle marking in this triangle so that you know we're using right triangles, not acute, not obtuse. They are all right triangles today, so they should all have the little perpendicular box mark in the corner. Pythagorean theorem relates the lengths of the sides of the triangle to the triangle's hypotenuse. And that formula that we're going to be using over and over and over again today is a squared plus b squared equal to c squared. Have y'all seen that formula before? Yeah. The thing that I need you to remember about Pythagorean theorem is that the hypotenuse, hopefully you remember that word in our Kahoot earlier, is the longest side, and it is always opposite of the right angle. So today what I'm going to have you highlighting while we do these problems is not all the side lengths, because it just gets crazy on our paper. What I want you to highlight always is going to be the hypotenuse. So for us, I just want to highlight side length C every single time. Oh, that's So we're going to be highlighting our hypotenuse so that we know which one's the hypotenuse versus the leg. The hypotenuse is also the side length C. So we want to make sure that we're always making that longest side, the hypotenuse, the C value. When you give me an answer for the Pythagorean theorem, there's three ways you can write it. The first way, and probably the one you're going to be most comfortable with, is in rounded decimal form. So look for how much I want you to round to, probably 2 decimals every time. So we'll make sure we round. But if it asks you for what's called an exact answer, your answer will be left in radical form. Now, if you notice, it had the word simplest right there, and I marked it out on your notes. I'm actually not going to have you simplify these radicals until maybe in a couple days I'll have you do that, because it's a skill that we've done before, but we're just really going to be working on Pythagorean theorem, so we can say it's just going to be in radical form, maybe not simplest radical form, and that's okay. Which means that your answer will be left underneath a square root, and that's absolutely fine. When we're dealing with Pythagorean theorem, there are some shortcuts we can take if you recognize the numbers. These numbers are called Pythagorean triples. A Pythagorean triple are just common trios of numbers that form right triangles. The most common Pythagorean theorem is the triple 3, 4, 5. If you have a triangle with legs that are length 3 and length 4 and a hypotenuse of 5, it is called a Pythagorean triple. It's just a really, really common side measurement for a triangle. Other common ones are 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now these other lists of numbers they have here are just multiples of 3, 4, 5, so like times 2, this would be 6, 8, 10. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, or vice versa. So they can get bigger and bigger with these numbers. As long as they're in that ratio, they'd be considered a Pythagorean triple. So as we're working through our problems today, we're going to find the values of A, B, and C, the lengths of the side and the hypotenuse. And I'm always going to ask you, do these form a triple? Which means if you look at these lists and you see the numbers there, you're going to say, yes, it's a triple. These are the common triples. Okay, let's figure out how this works. So I've done the first few problems for you, so you have nice clean examples. Number 1 says to find the indicated measurements. So we're looking for x, and then we're going to determine if it's a triple. Okay, what I want you to do when we're solving these problems is highlight the hypotenuse only. So I'm looking across from the right angle, and I want to highlight that hypotenuse, so the side length measuring 8. That way I make sure when I fill in a squared plus b squared equals c squared, that red number, that number for the hypotenuse, is the one by itself, because the hypotenuse number should go by itself. Other than that, you just fill in the numbers you have. So x goes for one of the legs, 4 goes for one of the legs, and you solve for x. What is the first thing I did here? Because I'm just doing math, but with words. What did I do to get from this step to this step? How did 4 squared become 16? Nah, guys, what is 4 squared? Type it in your calculators right now. There's a whole button for this little square.
Basically,
It's 4 times 4. 4 times 4 is 16. So we got to get used to using the square button today because it's totally a part of our formula. So in your calculator, press 4, and then the square button is like diagonal from 7. You see that it's got an X with a little 2 on it? That's the square button. Press 4, press that. What did you get? 16. All right, go to 8. Press 8, press square. What did you get? We're squaring these numbers. Now, how come I did not press X squared? Can you type X in this calculator? Not on the home screen. It's only for graphing. So we leave it as X squared. Okay, cool. I showed my work so you could see what's happening. What did I do to go from the one after I squared those numbers to this one right here? Take away 16. I did inverse operations. I crossed the line. I changed the sign. I didn't use a box method here because it's too easy. The one-step equation for me box method-wise. So I just subtract 64 minus 16. I get 48. Now here's where the interesting part comes in. I want X by itself. I don't want X squared. So how do you get rid of a square? Based on what I wrote, what should you do? What's that called? A radical. It's called a square root or a radical. So to get rid of a square, you're just going to square root this number. And here's where you get your two types of answers for me. Square root of 48 is called your exact answer. So if the question asks for an exact answer, you're giving me square root 48 because the square root of 48 is not a pretty number. But you can round that number when you put it in the calculator. So you would put square root, which is a blue symbol above the square key, so second and then that button. You type 48, you press enter, it's going to give you 6.93 and a whole bunch of decimals after it, and you round to 6.93. Okay, so this is what an exact answer looks like. This is what a rounded answer looks like. So depending on what I ask you, it's what you give me. But these are equivalent, so if you don't know if your radical is okay, just type it in the calculator, make sure it's the same decimal as your decimal, and then you're okay. Can we see another example? In number 2, we're still finding the lengths here, which means I'm looking for this side. I should highlight my hypotenuse. That's what I'm highlighting every time. We highlight the side across from the 90-degree angle, the right angle, and that's my C value. I want to make sure that that side length, which this time is X, is the only thing by itself. Every other number are my legs, and they go on the side with each other. So this time when I fill stuff in, I have a leg of 81. I have a leg of 108. I'm going to square both those numbers and add them together, and I get this giant number, 18,225. Okay, so I have this value X, and again, I have the radical version of this, and I'm going to call it radical, not exact, because if you type the square root of 18,225 in your calculator, it doesn't give you a decimal. It gives you an exact answer of 135. So I'm making a big deal about this because if you take the square root of the number and it comes out to be pretty, we're going to call this a pretty number. No decimals, it's a whole number. You answer with the whole number instead of the radical. But if it doesn't come out to be a pretty number, you go back to the radical and answer like that for an exact answer, unless you can round it. Yes, no, maybe so? Now the question I forgot to answer for both of these was to ask if they are Pythagorean triples. So my question when I'm asking is a Pythagorean triple is going to be, are the answers I got, the side lengths and the hypotenuse, a part of these lists? Do you see up here anything that contains a radical in any of these? Do you see this shape up there? No, so if your side length or your hypotenuse has this shape in it, it is not a triple. Not a triple. But if you get an answer that's pretty, all of the numbers being whole numbers, like in example 2, where you have 81, 108, and 135, those are all part of a triple. This is actually a scaled up version of this Pythagorean triple. If you take the number 3 and you multiply it by 27, and then 4 times 27, and then 5 times 27, that equals these side lengths. So this is a triple because I got nice pretty numbers as my answer. If you get a radical, it's not a triple. Otherwise, you're good to go. Whole numbers means triples. Okay, but here's the kind of question I'm wanting us to answer, because those are almost like 8th grade math style questions. We can do better than that. Number 3 wants me to find the indicated measurements. My end goal is to figure out this leg. Okay, that's my end goal, is to figure out that triangle. So if I look at only that triangle right now, the one that's tilted on its side, I know that this is a leg. I know that this is a leg, which means that diagonal that's across from the right angle right here, that's going to be my hypotenuse for my purple triangle. Okay, do I know two of those side lengths? I only know one, so I'm going to have to do some thinking to figure out one more side length so I can solve using Pythagorean theorem. We can only be missing one side length. Okay, but let's look for a second at the other triangle here. It's a right triangle, which means this is its hypotenuse. So my red triangle, this would be a leg, this would be a leg, and this would be the hypotenuse. So what we can do when these triangles are smushed next to each other is like split it into two problems. If we solve for the lengths of the red triangle, we can then solve for the lengths of the purple triangle. Follow along with me. We're going to do the red one first. In the red triangle, we always start by writing down a squared plus b squared equals c squared. We're starting with Pythagorean theorem, so I want to see the theorem written on your paper. The a and the b should be legs. What is the length of one of the legs of the red triangle? 6. What is the length of the other leg of the triangle? No idea. We're going to leave b right there. Actually, we'll change that to an x. That way it's solving for x. We're going to say, don't know what that is, it's x. What is the length of the hypotenuse? 9. So we're going to put 9 squared right there. Okay, let's look back at the steps we did for number 1. After I filled in my numbers, what did I have you guys do to get those bigger numbers? Square them. All right, in your calculators, 6 squared, please. Or brains. Some of us know that in our brains. 36. We cannot square x, so we're just going to leave it as x squared. And then we're going to do 9 squared. What is 9 squared? 81. Okay, cool. We got our big numbers. What was the next step in number 1? Subtract. So I'm going to subtract 36 to the other side. 81 minus 36 is what? Is 45. Okay. I'm glad you said that, so don't get ahead of me here. In this problem, if we were to do the square root of 45, does it come out to be a pretty number? No, so we're just going to leave it as square root of 45. For those of you wondering, it's approximately 6.71. I don't want the decimal form in the middle of a problem. You only give me a decimal answer at the very end. So we're going to say for the red, x is 45, or sorry, square root of 45. Awesome. So what that means for me is I have now found out that this leg is the square root of 45. Well, since the hypotenuse of the purple is the leg of the red, I can now take this value, this square root of 45, and apply it to the purple triangle that's touching it. Using Pythagorean theorem again, a squared plus b squared equals c squared. I need leg lengths first. What is one of the leg lengths for the purple triangle? 4 squared. What is the other leg length? Don't know. X. What is the hypotenuse? Square root of 45. Now notice, I have put that square root of 45 in parentheses. I need you to do the same thing, because you might accidentally square the wrong part unless you put the whole thing in parentheses. All right, calculator moment, because we didn't round. We want to leave it as the square root 45. We do 4 squared. What is that? 16 plus x squared. Don't touch it because it's an x. And then I want you to put that whole thing in the calculator. Parentheses, square root 45, close parentheses, squared. So if you square something that's square rooted, it's just the number. A square and a square root are inverse operations, so they will cancel each other out. So if you're squaring a square root, just take the number out of it. You don't even have to type that in the calculator anymore. Just take the number out. They're inverse operations. Okay, repeating my steps again, I'm going to subtract 16. 45 minus 16 is 29. When you take the square root of 29, does it turn into a nice pretty answer? No, but now that we're at the end of the problem, we can round. So the square root of 29, if you put that in the calculator, is approximately 5.39 units long. Oh my goodness. We had a double problem within this one problem. Questions, comments, concerns about this? This one's a little bit more challenging than number 1 and number 2 because we had 2 triangles smushed up next to each other that we had to solve independently to get our missing leg length. Nothing right now, right? Maybe questions later? Okay, on to the back we go. We got some word problems because triangles are going to appear a lot in real life. So we need to be able to situate ourselves to real life. This is similar to the shadows questions we had when we studied similar triangles, like how the shadows were at different times. I drew you a picture because the number one thing you can do for these problems is draw a picture. And we're going to be drawing lots of pictures in the next few days to make sure we understand what information I've given you. Please don't make fun of my house or ladder. It's pretty. How far from the base of the house do you need to place a 15-foot ladder so that it reaches the top of a 12-foot wall? Okay, this is the situation I have. I'm leaning a ladder against my wall. How tall is this wall? 12. So take a number 12 and I want you to label that side length as 12, which means yes, you're kind of riding over the house a little bit. That means that the height of this itty bitty triangle that I made in here is 12. It tells me information about the ladder. How long is the ladder? 15 feet. So you put the 15 along the ladder diagonally. That's your hypotenuse. And it says, how far do I need to place it? Which means that this leg right here becomes our x, becomes the thing we're searching for. Now, to balance out how I worked these problems in the front, I'm highlighting the hypotenuse just so I remember which side length should be by itself. I'm going to start this problem with you, and then I'm going to let you finish, because once we do a squared plus b squared equal to c squared, you should know exactly what number to put where. The only thing I'm going to help you with, what number should be c squared right now? 15. So I give you this. I want you to finish this problem, and I want you to figure out what that side length should be, what x should be for us to lean this ladder against the house. The steps are on the front of the paper. We just did some problems like this if you need to look back at how to do them. Okay, what was one of the leg lengths? 12. Do we know the other leg length? No, so we're going to leave that as our x variable, as our missing side. Okay, we square those numbers. 12 squared is 144. 15 squared is 225. What's the next step? Subtract. Minus 144 on both sides, which means this becomes x squared equal to 81. When you take the square root of 81, does it come out to a nice pretty number? Yeah, so we don't want to answer with a square root if there's a nice pretty number we can use. If it asks for a rounded answer, you can give the rounded answer, which this one actually does ask for the rounded answer, but I like knowing the exact answer as well as a rounded answer if possible. Questions, comments, concerns on this for those of us who hadn't finished it before I started talking? Okay, number 5. Number 5 is an interesting question. It says the area of a rectangle is 99 square units. Its width measures 9 units. Find the length of its diagonal. Here's some important things for you, and this is like truly life lesson important. Imagine this is a TV. Did y'all know that TVs are not measured by their width or their height, but they're measured by the diagonal across the TV? So when you say you get a 55-inch TV, it's not measuring on the side, it's measuring on a diagonal. So this is applicable to you if you ever go shopping for a TV. You'll actually know how wide or tall your TV is about to be, so you buy the right mounting equipment and or, what's the word I'm thinking of? Like the thing it sits on. TV stand. What? Okay. So here's what we know. In this problem, it says that the area of the rectangle is 99 square units. Its width, how wide it is 9 units. You see how I'm adding numbers to an image as I go? It wants me to find the length of its diagonal. It wants me to find this hypotenuse. What would, if this was a TV, what the measurement of that TV would be? Okay, I notice that this makes a right angle, which means I can use Pythagorean theorem to figure out what this diagonal is. The only problem being, I need to know this height if I'm going to be able to do a squared plus b squared equals c squared. But I'm given the area of this rectangle. How do you find area of a rectangle? Oh, wow, that's base times height, or length times width. Yes, I'm going to use length times width. So if we have length times width, we were told the width is 9 square units. So let's solve this problem that says the area would be 99 square units if I multiply the length times the width. What do I have to multiply by 9 to get 99?
10, or no, not 10.
11. So the length of my TV is going to be 11 units. By the way, that's a cursive L. That means I can make this 11 units, not square units. So when I go in and I start to do my Pythagorean theorem, I now have 2 legs and I'm able to find the hypotenuse. So we put a squared plus b squared equals c squared, and we fill in what we know. Reminding ourselves that c squared should be that hypotenuse. What is one of the legs? 9. What is the other leg? Woohoo, we know them this time. Which means we're just looking for c squared. We're just looking for that x. Now this problem is actually easier. Do you notice that all of the numbers are on one side and x is already by itself? There's no adding or subtracting here. There's just computing. So in your calculators, I need you to type this whole thing in. 9 squared plus 11 squared. One time. 9 square plus 11 square. Should be one line of your calculator. Thank you, Chris. What'd you get when you do 9 squared plus 11 squared? 202. So 202 is equal to x squared, but I don't care about x squared, I care about x. So what did we do to get that square to go away? We would do the square root of 202. If you throw that into a calculator, it's not going to give you a nice pretty answer. So we are going to round this one to the nearest 2 decimals. I'm sorry, the thing up here says the nearest tenth. So that's 1 decimal. So in your calculators, please, can you figure out what the square root of 202 is and round it to 1 decimal? 14.2 units. So if you were buying this TV, if this was a TV, it would say that its measurement, this is a 14.2 inch, that's tiny, TV. Your laptop screens are measured by diagonals. Most technology is measured not by lengths and widths, but by diagonal. Just FYI. Next problem. What does it say on it? We're skipping. That's for honors. We're going to go down to this last little bit here, which is about the Pythagorean theorem converse. So another way we would use Pythagorean theorem is to determine or classify a type of triangle. Notice when I'm doing this Pythagorean theorem, it's not a squared plus b squared equals c squared. I'm putting c squared first on purpose. if you do c squared equal to a squared and b squared, and you actually get an equal sign right here, that the left side is equal to the right side, what that tells us is that the triangle is a right triangle. So we would have the right triangle symbol there. If you calculate c squared and a squared, b squared, and the hypotenuse squared is less than the other two sides, since it's less than, it's smaller. What's smaller than a right triangle? Or it's an acute triangle. If you calculate c squared and then a squared, b squared, and c squared is bigger than the legs, what is bigger than a right angle? Obtuse. That makes this an obtuse triangle. So we are going to be able to classify our triangles from Pythagorean theorem itself, which is really nice. The trick with this is to make sure you know which side lengths are small, medium, and large, so that you make sure to put C by itself. So when I'm doing these problems, I'm going to put A, B, and C over the numbers, small, medium, and large, so I know where to put them in my formulas. Is that okay? When I do this problem, I've done 2 of them for you. You're going to finish 2 of them for me. I'm always setting this up. I put it in a cloud so you know how important it is. We are trying to figure out, is C squared less than, greater than, or equal to a squared plus b squared? But I know that c squared has to be my longest side. So I grab that longest side, I pop it here, and I put the other 2 lengths here as legs. We calculate. 26 squared is 676. I would type in my calculator. 22 squared plus 14 squared, I get this number. Which one's bigger? 680 is bigger, so I'm going to put the mouth open towards the 680, and I have used the less than sign, which means that this triangle is acute. Remember, less than sign is acute. Same thing in number 8. I looked for the biggest side length, C, and I made sure that one was the one by itself. And I evaluated both sides. These numbers were exactly the same. So I put an equal sign right here, which then means this is a right triangle because they're equal to each other. Yes, no, maybe so? Let's try one. All right, we're looking at 11. First thing I did was decide which one was biggest, smallest, and medium. Right now, can you tell me which one's biggest, smallest, or medium?
3.
How can we be sure what 3 square root of 34 is? Yeah, let's put it in the calculator. Put 3 and then square root of 34 in your calculator just to see what number that is, and we can compare it in our brains to 9 and 15.
17.5.
Yeah, 17.5-ish. Okay, so which one's the biggest? 17.5. So if I was labeling these, I would label it small. This is A, then B, then C. So I'm going to make sure this number is the one by itself. Not the rounded version of it, but the square root version of it. So I set up my little equation. I say, okay, C squared is going to be something to A squared plus B squared. I'm going to put that C squared in here. 3 square root of 34. All of that squared. And then I have A squared and B squared, which is 9 squared plus 16 squared. I need to calculate both the sides of this. So exactly as it's shown, you type it in. Parentheses, 3 square root 34, close parentheses, squared. Type, type, type. We get a number. What did you get? I'll give you a second. $306. Okay, now I need to calculate the other side so I know what symbol to put in that box. 9 squared plus 16 squared. I said 16 this whole time. That number is a whole 15. Y'all stop me when I'm doing something crazy. What did y'all get? Should be 306 again. That one's on me if you type 16. Okay, how do these numbers compare to each other? They're the same, so they're equal, which means we classify this triangle as a... Which one is equal? A right triangle, absolutely. All right, we only have one more example here to classify for triangles. Can I let you do this one start to finish? You got it. Identify A, B, and C, which one's small, medium, and large, and then do a problem just like this. Should see some more writing on our papers. I'm going to start working this quietly if you're stuck, but I need you to go faster than me. Did you guys get the same as me? Where 1.3225 and then my box and then 2 on the other side? So I'm using this symbol because the 2 is bigger. What does that mean about this triangle? Is it right, acute, or obtuse? Acute, very good. So if I'm asking you to classify the triangles, this is the kind of problem you're setting up. It's like the backwards Pythagorean theorem where C comes first because we want to compare to the big side, to your hypotenuse. Okay, before we get into our levels for today, we are going to do one more Kahoot. So you still have your computers up. Let's get logged back in. This will be a regular Kahoot from start to finish, so there will be winners if you compete for quick bucks. And then we'll move to our levels for the day.